Okay, so right here, this is the station for arithmetic sequences with the recursive formula and the explicit formula, and we're going to look at different ways we can use these to look at these sequences. So right here on the first one, we see we have 2, 4, 6, and 8. So I want you to be able to find the next 3 terms in the sequence. So we're looking at this sequence right here. So our next 3 terms right here, we see it going up. So we're going to find our common difference. So our common difference would be 2, going up by 2, going up by 2. So our next term, we know, would be 10, 12, 14. Alright. So we see as it's going up, you can find that. So now we know it's just going up by 2, so it says find the 42nd term. So here, all we have to do, since it's only going up by 2 every time, repeated addition is same as multiplication. We just say 42 times 2. Alright, what's that equals? 84. Alright, now we're going to determine the recursive definition. So, or the formula. So we know our formula for this is a sub n equals a sub n minus 1 plus the common difference. Alright. So right here, we see that our formula here will be a sub n equals a sub n minus 1 plus 2. And we know a sub n means the term you're looking for. It can be any term. So, and then a sub n is the previous term. Alright, right here, looking at this one. To determine the explicit formula here. So we're going to look right here. You see our formula for explicit form is a sub n equals a1 plus n minus 1 times d. Alright, we know our common difference is 2 because it increased by 2. Our first term here was 2 because our sequence goes 1, 2, 3, 4 for all our x values here. So our first term is 2. Right here we'll say, alright, a sub n equals 2 plus n minus 1 times 2. Distribute here, get 2 plus 2 minus 2, or excuse me, 2n minus 2. So 2 minus 2 is 0, so a sub n equals 2n. So that's my explicit formula. That means I can plug in any term for n and get that number in our sequence. Alright. Right here, same thing. What is our common difference here? Label it out. 1, 2, 3, 4. Just like a table, that'd be x and y values. So we see it's going up plus 3, plus 3, plus 3. So our common difference is 3. So add 3 to every one of them. That'd be 17, 20, 23. Alright, right here. Okay, let's wait to do this one. We're going to use our explicit formula to do it. Our recursive right here would be a sub n equals a sub n minus 1 plus 3, and we know our first term, which is A1, would be 5. Alright. Now, determine our explicit formula. We're going to substitute it in. So we got A sub n equals 5 plus n minus 1 times 3. That's going to give me 3n minus 3 plus 5. Subtract those two. A sub n equals 3n plus 2. So that's our explicit form. Come up here, find the 33rd term. So we got A sub 33, because that's the term we're looking for, equals 3 times 33 plus 2. Alright, and 3 times 33 is going to be 99 plus 2, 101. Alright, next problem. Same thing here. We'll have our explicit form. So we're going to find our common difference here. I know that's 1, 2, 3, 4. Alright, so it's going down by 3. So our difference is negative 3. So 1 minus 3 is negative 2, minus 3, negative 5, minus 3, negative 8. Alright, so now let's do our first term here. A1 equals 10. Alright, so now A1 equals 10. We've got A sub n equals A sub n minus 1 minus 3. Right over here, our first term was 10. So we got A sub n equals 10 plus n minus 1 times negative 3. So it'll be 10 minus 3n plus 3. Combine your like terms. A sub n equals negative 3 n plus 13. So let's find the 29th term. A sub 29 equals negative 3 times 29 plus 13. So we have 3 times 29. Let me get my calculator. Alright. So we get. Alright, so I get the 29th term here to that equation. After we simplified it, we get negative 74. Okay, next. Determine the common difference in the sequence. Write a function that could be used to describe the sequence. So right here, if we look at this one, you see it's going down. So our common difference we can see right here. We got the second term, 11 minus 14. It's going to give me a negative 3. So my common difference is going to be negative 3. Alright, so a formula we could use here. So I'll use my formula. So we'll use our explicit formula. A sub n equals 14 plus n minus 1 times negative 3. So A sub n, or we can change it to y. We'll do it at the end. It's 14 minus 3x plus 3. Combine your like terms. You get y equals negative 3x plus 17. So that's a function we can use. Next, write the recursive relation and explicit definition. Alright, so right here, looking at this, we'll find our pattern here. We see that it's going up by 2 every time. Okay. So we see it's going up by 2 every time. So our recursive, we know our first term here a sub 1 equals 5. So we'll have a sub n equals a sub n minus 1 plus 2. So that means this is our previous term, so any term we put in there added will give us our next term. So if I want to find the 6th term, I know I'll look at the 5th term, which is 13. 13 plus 2 is 15. So that's what we'll do. Alright, next is our explicit formula. So right here, we got a sub n equals the first term, 5 plus n minus 1 times 2. Alright, distribute that out. A sub n equals 5 plus 2n minus 2. Combine those two, we end up getting y equals 2n plus 3. Alright, lastly,